Welcome to Intermediate Algebra, Chapter 1, Section 7. We're talking about absolute value inequalities. And we've already talked about absolute value equations. And in an absolute value equation, like this one, we said that, using very technical terminology, we said that the stuff inside the absolute value as a very first step, or sometimes as your second or third step in the process of solving an absolute value equation. But once you had the absolute value all alone on one side of the equation, in other words, isolated on one side of the equation, your next step was to write two separate equations where the stuff inside the absolute value bars was set equal to the original value that was on the other side of the equation and set equal to the opposite of the number on the other side of the equation. Unless the number on the other side of the equation was originally negative, and then we said there's no way to have an absolute value equal to a negative number, in which case there was no solution. In absolute value inequalities, there are two different scenarios. Once you have the absolute value isolated on one side of the inequality, it's either going to be on the greater than side of the inequality, or it will be on the less than side of the inequality. Depending on which of those two circumstances you run into, you have to take a different course of action. And one of the ways that I remember personally what to do is, if the absolute value is on the, what's that symbol called? Here the absolute value is on the greater than side of, in this case, the number a. And instead of saying greater than, I say greater than. And I say that because the first step after isolating the absolute value, when it ends up on the greater than side of the inequality, is to write two separate inequalities where you don't have any absolute values anymore. And the first inequality that you write, the one I do it, is I write it so that it looks exactly like the original statement, except it doesn't have any absolute value bars. And then I write the word or, and then I'll write a second inequality where the number gets negated, the inequality sign gets flipped. You'll notice that this inequality symbol has been flipped compared to this one. So we have to flip the inequality symbol, and then whatever the expression was that was on the, or that was in the absolute value bars, it stays the same, but the other two components change. The number gets negated and the inequality sign gets flipped. Okay, that's one scenario. And the second scenario is when the absolute value is on the less than side, and instead of saying less than, I say less than. And the word and being in there is what reminds me that I need to write it as a compound inequality. I could use the exact same strategy as we did with when it was on the greater than side. I could write it as two separate statements with the word and between them, but this is going to end up being a much more efficient technique. So I recommend that you use this one. And what I like, one of the things that I like about the way that you can set this up is, if you look at this original inequality statement, here's the x and the less than symbol and the a, and here's the x and the less than symbol and the a. Those three components are pretty much identical, except you don't have absolute value bars over here anymore. And then there are these other two new components, and those new components consist of the exact same symbol here. The mouth is opening, facing in the same direction as the first one was, so that's like a copy and paste. And then here we see the opposite value is being used. So what I'm going to do in this video is go through an example of each one of those, and if I spot any really unique problems, I will make sure to address the elements of that. And then at the end of this set of notes that I have here, there are a couple of word problems, and we'll do one or two of those. Sorry, this box that we were looking at here is also nice because it gives an illustration of how your solution set could be presented on a number line, and sometimes these solutions on the number line are going to have parentheses, which all of these do. Parentheses, or open brackets we call them. But if one of these symbols has an or equal to in it, then instead of parentheses we will use the square brackets or closed brackets. And that's what we're going to be doing in this first example. We're going to end up using the closed brackets or square brackets because the inequality symbol has the or equal to symbol in it. And I wonder, actually, let's do this one just because it involves a couple of other additional steps. But let's modify it and let's go ahead and put the or equal to symbol in it. So greater than or equal to. And let's go through the motions on this one. So sometimes the absolute value is already the only thing on one side of the inequality. That's the case in this example too. It's already isolated over here. But in this problem, it's not. So let's work on this problem number 1. The first thing I'd like to do is add 7 to both sides, and then we're going to divide both sides by -3 in order to isolate the absolute value. So let's add 7 to both sides. We get -3 times the absolute value of x minus 1/2 is greater than or equal to -6. And then, so I added 7 to both sides in order to do that, and then the next thing I'm going to do is divide both sides by -3, and I'm glad that we're doing that, because on the left-hand side of the equation, or of the inequality, we end up with x minus 1/2. Absolute value bars are still there. On the right-hand side, a negative divided by a negative is a positive, so we get +2 on the right-hand side. And don't forget that when you multiply or divide by a negative number, we need to change the inequality symbol or flip the inequality symbol. And so right here, I'm going to put greater than or equal to, or sorry, less than or equal to. Regardless, flip the sign. Okay, now we have the absolute value, and it's isolated on the less than side, which means we're going to create a compound inequality. And just to make sure that I don't, we won't run out of space. So let's write this as our compound inequality. My pen wasn't working, sorry. The x minus 1/2 is still there without any absolute value bars. The less than or equal to symbol is there. The 2 is there. All that stuff is the same. And then we copy and paste. We put that same inequality symbol to the left of the original left-hand side and the opposite numerical value. So this is the statement that we're working with now, and we're going to isolate the x in the middle region, so to speak, of this compound inequality, and we're going to make that happen by adding 1/2 to all 3 regions. And what that gives us on the left-hand side is -1.5, or -3/2, is less than or equal to x, is less than or equal to 2.5, or 5/2. I'm going to convert them into mixed numbers in a moment. So this is one way that you could present your solution to this problem. Another way would be to write it on a number line. So I'm going to write myself a number line here. I have -3/2, I have +5/2, and literally my x values are between the two. So when it's time to shade the number line, and it is time to do some shading, I'm going to shade between those two values. And the other thing that needs to happen here is, as I mentioned at the outset, because it's a less than or equal to symbol that we're working with, we need to be using square brackets. That's going to make sure to include the values of -3/2 and +5/2. So that is your solution on a number line. And the only other, or the maybe most frequent way that you're going to see this solution presented is using interval notation. As you might know already, I love translating a number line down into interval notation because I get to use the same symbols as I was using on my number line, which are including those two values, and then the -3/2 goes in here, comma, +5/2, and that, ladies and gentlemen, is your solution using interval notation. So this was an example of where once we had the absolute value isolated on one side of the statement, this one was isolated and ended up on the less than side. Now let's look at a problem where we have our absolute value on the greater than side. Let's do number 4. So we do have to do a preliminary step here where we subtract 2 from both sides. So we have now the absolute value of 2x minus 1 is greater than or equal to +5. Let's make it strictly greater than. Let's just make it greater than. That way we've got a little more variety in our problems. And it's not a 5 because I subtracted 2 from it, so this should say 3. Okay, so the absolute value of 2x minus 1 is greater than 3. The absolute value is on the great or than side of the statement, which means we're going to be writing this as two separate inequalities separated by the word or. The first inequality looks exactly like the original. 2x minus 1 is greater than 3. There's my word or. And then the left-hand side of this statement is going to stay the same. 2x minus 1. The inequality sign is going to flip, and we're going to negate the numerical side. And then we're going to work these two inequalities the same as we ever have. And we really work them just like we do with an equation, unless we multiply or divide by a negative, and then we have to switch the inequality symbol. But I don't think we're going to run into that here. Okay, so let's add 1 to both sides. I'll put a little note here that we're adding 1 to both sides. So now we have 2x is greater than 4. And in this statement, we're going to add 1 to both sides. 2x is less than -2. And then back to the left-hand side, I'm going to divide both sides by 2 in order to isolate my x value. So x is now greater than 2. And on the right-hand statement, I'm going to divide both sides by 2 in order to isolate the x on the less than side. So x is less than -1. We're getting pretty close. I don't think you would ever present your final answer like this. So maybe I'll just circle them instead of putting a box around them. I would say that this definitely needs to be put on a number line. Let's see what it looks like. I have a -1. I have a +2. And as far as the +2 is concerned, this says that we like all of the x values that are greater than 2. So I'm going to shade to the right of the 2. And we're not going to include the 2 because it's a strict inequality. So I'm making sure to use a parenthesis or open bracket, not a square bracket. And the 1, x being less than -1, so we need to shade to the left of the -1. If my pen will work. There we go. And again, it's a strict inequality, so we're going to get the parenthesis on there. And really, at the ends of these shaded regions, you would typically see an arrow, which indicates that the shading is going all the way down toward -infinity or all the way up toward +infinity. All right. The shading on those lines was maybe a little too enthusiastic. I think next time, yes, that'll be better next time. Okay, This statement's a little bit unique because even after we multiply both sides by 2 in order to get rid of this 1/2, this side is still going to be a 0. So you're going to have an absolute value that's greater than 0. Greater than 0. That one's going to be a little bit unique, but work it out. Realize that it's going to be a little bit unusual, and you will still be able to put it on a number line, but I'll give you, I'm just going to let you work it out. Just realize that it's a little bit unique with it being greater than 0 like that. This problem, divide both sides by 2, proceed as usual. And then let's take a look at this first example problem, or this first word problem. When a number is subtracted from -7, the absolute value of the difference is more than 3. Oh, got it. I was like, is more than 3 what? So when a number, let's call that x, is subtracted from -7, so here's the -7, and we're going to subtract this unknown number from it. The absolute value of the difference, this is the difference. When you subtract 1, if I asked you what's the difference between 3 and 5, you would say 2. How do you get that? 3 minus 5 is -2, but what's the absolute value of -2? It's 2, so you would say the difference between 3 and 5 is 2. And it's a difference because it's a subtraction problem. The absolute value of the difference is more than, so that's the greater than symbol, 3. So this is greater than 3. Well, that was the hard part. You know what to do from there. It's a greater than, so you're going to have 2 statements separated by the word or. Identical coming into here, and the difference over here is that it's going to be less than -3 because you'll switch the inequality sign, negate the numerical value, and the left-hand side will be still the contents of the absolute value. Alright, so those are the 2 statements that you're going to work through. A landscaping company sells 40-pound bags of topsoil. The actual weight of X bags, the actual weight X of a bag. Oh, so the actual weight of a bag is X. However, may differ from the advertised weight by as much as 0.75 pounds. Write an inequality involving absolute value that expresses the relationship between the actual weight, X, of a bag and 40 pounds. Interesting. That's very strange. So the actual weight of our bag must be less than 40 pounds plus 0.75, because they could differ by as much as 0.75 pounds, which means your 40-pound bag of topsoil could conceivably weigh 40.75 pounds. However, it's also possible that you pay for your bag of soil and you got shorted, and your bag of soil only weighs 40 minus 0.75 pounds. So your bag of soil is going to weigh somewhere between 39.25 pounds and 40.75 pounds. Solve the inequality. I think maybe I just thought of this too logically right off the start, because the inequality is already solved. X is all alone in the middle of our compound inequality. And then they want us to express the answer in interval form. We could drop it onto a number line, but if my X values are between those two values, I suppose it could actually equal 40.75 pounds or 39.25 pounds, so let's make those less than or equal to symbols. And then if we want to put this into interval notation, because of the or equal to part, we want to use square brackets, and our x values are somewhere on that closed interval from 39.25 all the way up to 40.75. I hope you run into more difficult problems than that on your homework. That seemed too easy. I almost feel like a more difficult problem will be easier to set up. Maybe we'll just be scratching our heads at these word problems no matter what. Hopefully this gives you a good introduction as to how to situate, especially the first couple of steps of solving an absolute value inequality statement. Don't forget that if you multiply both sides or divide both sides by a negative number, that you need to switch the sign. And don't forget to use parentheses or square brackets whenever it is appropriate. See you soon.